So we're gonna learn how to solve exponential equations in two different ways. Okay, graphically, and then also using just algebra. Now, with the graph, what we're going to do is we're going to use the calculator. That's what we're going to do on this first one. So it gives you this given equation right here. There's my exponential equation. 3 times 2 to the x power equals 96. Now, we did something similar to this before in some other lessons where we graphed two different things when we were looking at the absolute value equations, when it was equal to a numeric value, and we drew a horizontal line on the graph, and we drew the absolute value function on the graph and saw where they intersected. Y'all remember doing that? Yes? No? Kind of so. Kind of looked like this. We would graph, and here was our absolute value. Then we draw a horizontal line and look for those 2 points. Y'all remember doing that? Okay. This is the same type thing here. We're going to do the same thing. Now, what it does, it wants you to actually graph them here. We're going to skip all this. So we're not going to fill in the table and plot points and graph. How do I know it does like that? Anybody want to take a shot? How do I know it does like that? Do what? There's no negative. What else? It's not a fraction. Exactly. My base number is 2. Therefore, it has to be growing, increasing, okay, going up. All right. So here's what I want you to do. On your calculator, when you do this particular problem, we're going to put in 2 functions. The first function we're going to do is this one right here. So we're going to go to y equals. We're going to type that in, 3 parentheses 2 raised to the x power. Then for y2, so we're going to go right under that. For y2, we're going to put in the constant function. y2 equals 96. Now, here's the thing you must be aware of. We're talking about a y value of 96. Our standard window on our calculator only goes up to 10. So what I need to do is I need to fit my window to help me graph. Now, this is where the textbook is helpful, because right here, they kind of already set up the window for you. So on your calculator, press window. We're going to do our values here based on what they have here on the graph. So my x min is going to be -3. My x max is right here at 9. And my x's go by 1s here. My y min, okay, you may have to look very carefully here. What are my y's going by? 12s, okay? So my y min here is -24. My y max is
132. 96.
how about 120, right? You're going by 12s. That goes up to 120. So your y scale is 12. Okay, now press graph on your calculator. So the first one it graphs is your exponential. Then it should graph a horizontal line. So what you see, and this is not going to be exact here, but you see something kind of like that, right, on your calculator. So on the calculator, it's very easy to find. Where do we go to find this? You press second, trace, calculate. Which one are we going to use? Number 5, intersect. And then all you have to do is press enter 3 times. First curve, it should be on your exponential. Second cursor, it should be blinking on your horizontal line. And then guess, press enter. And where do they intersect?
596.
There you go. The point 596. And we're done. So here's a problem, an example, and I'm going to work this one out with you where they do it algebraically. So example A is already worked out. We're going to do example B, and then I'm going to have you try a couple of them algebraically. Now, the thing about doing it algebraically is you've got to know some values. You got to know some exponential values, and that'll make sense here in just a second. Okay, so let's go ahead, start filling this in. We have our equation already set up for us. And what is it we're always trying to isolate in this case?
The
What are we trying to get by itself? The what?
base.
Variable, the x, okay? That's what you're solving for. So you got to get rid of everything that's with that. So what's the first thing we get rid of?
A.
The a in this case, which is
2.
2. We're going to divide both sides by 2. So those 2's cancel. When I divide this by 2, remember division is the same as multiplying by the reciprocal. So dividing by 2 is like multiplying by 1/2. Now, if you can't do that, can you do it on the calculator?
Yeah.
Absolutely. You want to leave it in fractional form. So you do math frac. Either way, you should get 125 over 27. Now, what it wants us to do is it wants us to rewrite these using exponents, okay? So 125. This is always my clue right here. The base number on my exponential function. In my numerator, the base number is 5. So I need to rewrite 125 as a power of 5. Okay, so that is 5 to the third power. I need to rewrite 27 as a power of 3. Well, 27 is also 3 to the third power. This is where you have to know some exponential values. This is what I was talking about. You need to know 5 to the third is 125. You need to know 5 to the fourth is 625. You need to know 3 to the fourth is 81. You need to know 2 to the fourth is 16. Those are some basic values that you need to know. Now, if you don't know those, what can you do?
Multiply 3 by 3 by 3.
There you go. Go on your calculator, multiply 3 by 3 by 3. Or even do this. Go to your calculator to y1, put in 3 to the x power, then do your table set to start at 1 and go by ones. And then you can see 3 to the first is 3. 3 to the second is 9. So forth, so on. Okay, and that'll give it to you in your table in your calculator. Any questions? So it says rewrite the right side as a power of 3. That's what we did here, power of 3. So 5/3 to the x is 5/3 to the third. So what is x? X is 3. That is what x has to be in order to get that value. So I'm going to do the number 6 here, work it out with you, then I'm going to give you a couple minutes here to try and work number 7. So again, we're always trying to isolate the variable. So the first thing I want to do is I want to divide by 2/3. Now, that's not how I would do it. If I were doing it, I would actually multiply by what? Reciprocal. I would do 3 over 2. Now, it's completely up to you how you do it. This makes more sense to me because all that cancels. So I've got 3 to the x equals, and I can rewrite that as 18 over 1. 2 goes into 18, 9. 9 times 3 is 27. Now, what I need to do is I need to rewrite the number 27 as a power of base 3. Okay, so if I'm using base 3, how do I get 27? That's 3 to the what power? Third. We just did that. 3 to the third. So what is x here?
3.
X is 3. So I want you right now, take a minute or so, see if you can solve number 7. Then I'm going to put it up here, and then we'll check it. Okay, let's check it. Is that what we got? X is 2? Okay. Now, these can become more difficult the more elaborate the equations become, which is why we keep a calculator, because if we get big values, it's really hard to kind of do that by hand, okay? However, you do need to understand how to solve these algebraically. Again, on the state test, without the calculator, you could see a problem like this. Questions? So all I'm going to do here is I'm just going to read the problem. I'm going to skip all this other stuff they've got here as far as filling in, and then we'll go over and we'll look at how to solve it. It says an animal reserve has 20,000 elk. Now that's important. That is our starting amount, okay? The population is increasing. Again, an important word. So let's stop just a second. If it says increasing, what does that mean about our base number, B? Has to be what? Bigger than 1. It's got to be growing, so it's got to be bigger than 1. It increases at a rate of 8% per year. 8% per year. So we just talked about this. If it's increasing by percentage, that means that base number is not 8%. How would we represent that base number if it is increasing? What is our B? What is 8% as a decimal?
0.08.
0.08. That's not what we put as our base number, because we said it's increasing. So it's a number bigger than 1. So what would our base number be?
1.08.
There you go. Our base number B is 1.08, because we're getting 100%. We don't lose any of those 20,000 elk, okay? We keep those, but then we grow 8% per year, so it's 1.08. Again, a huge concept to understand. It says there is a concern that food will be scarce when the population has doubled. That means we're looking for it to be 40,000. How long will it take for the population to reach 40,000? So in terms of our equation, it talks about formulating a plan and getting a y1 and a y2. So that's what we're going to do here on the next. Okay, so as we read through this, we're trying to figure out what everything is, and we've already figured out one of them. We already said B represents the increase, which we said was 1.08. If it had said decrease, then that number needs to be something that's what again? A fraction, decimal that's less than 1. What does A represent? Okay, this, do what?
Population.
Exactly. It represents your starting population. What was our starting population?
20K.
20,000. Okay? 20,000. So that function is 20,000 times 1.08 to the t power, where t is the number of years. So this is not growing linearly, okay? We're not getting 5 new elk every year. It's growing exponentially. Now, why does that happen? Because every time an elk is born, that elk grows up to be a what? An adult. And then those adults do what? Okay, eventually. But what are they doing? They give birth to more elk. So the population just keeps growing. Think about history for human population. It has continued to grow. Natural death obviously keeps things in check, as well as diseases and other things like that. But in terms of growth here, that's why it's an exponential and not a linear. So we want to find when the population is doubled, 40,000. Now they told you 40,000, but in the problem they didn't have to tell you. They could have just said doubled, and you should have known that's 40,000. So what's our equation become? 40,000 equals 20,000 times 1.08 to the t power. Do we want to solve this one algebraically? No. This is a hard one to solve algebraically. How do you determine when to solve algebraically and when not to? Very easy. That is this right here. that's a decimal. Think about the problems we solved. They were all written as what?
Even numbers.
Fractions.
They were written as fractions. Because if they're fractions, you have a base number that can be raised to a power. Does anybody know what 1.08 to the second power is? No, nobody knows that. It's not common, right? But do you know what 4/3 to the second power is?
16 over 9.
16 over 9. We can do that easily. Do y'all understand algebraically? Okay, so here's what I want you to do. On your calculator, you're going to put these in as y1 and y2, and you're going to find where they intersect. Okay, so I'll give you just a minute to do that. Okay, so before I actually get a numeric answer from you for what you got, let's talk about our window. Because again, if you're going to do these on the calculator, you have to see where the two graphs intersect. So let's talk about our x-min. What is x in this particular problem? It's not actually x. What is it?
Year.
It's t, which is years. So let's talk about minimum. What would x-min be? 0. You can't have a negative number of years. Exactly. What would x-max be?
10, 20, 25.
Okay, we have no idea where they intersect, okay? But if you are going to set your graph up, you have to visually see where they intersect. Okay, so you could do 10. You might do 15, you might do 25. Do we know how many years it's going to take? No. So this is just a guess, okay? So I did 15. If I'm going from 0 to 15, what could my scale be?
1.
I can go by ones there, okay? 15 hash marks, I can go by ones. Does everybody get that concept or not? Okay, now going back to your point, you never, ever, ever type in an actual date, year, in a calculator. Never. Remember problems we did that were linear. If you start from 2016, 2017 would be represented by what? X is what? Nope. Never type in a year. What would 2017 be?
0.
1. Where did we start from? 2016. What is another word for starting point? Your what term?
Y-intercept.
Your y-intercept, which is called your zero term. That is your 0. Any sequential year after that is a year added. So 2017 would be 1. 2018 would be
2.
Do y'all get that concept?
Yeah.
Yes? That's a huge one. We've done it over and over back when we did linears. They're making this easy, but you need to still understand that. Y-min. What's the minimum value we can have for a Y? Well, what does Y represent here?
The number of elk.
Exactly, the population of elk. What's the minimum we have?
20,000.
20,000. We started off with 20,000. What does my Y max need to be? At minimum what? 40,000. I actually need to see on the graph where they intersect.
42.
So I went a little bit above. You could go 42. I went 41. Okay, something above that where you can see it. Okay? If you just do 40,000, it's going to intersect at the very, very top of your calculator. And that's not very helpful. What should my Y scale be here?
2,000.
Okay? That's a difference of, right here, 21,000. Needs to be a big number. Okay? So you could go by 2,000s. You could go by 5,000s, whatever. Okay? Everybody good? Okay, now if you graph it, you should see where they intersect, yes? Okay, so second, trace, calculate number 5, and then just press enter 3 times. And where did they intersect at? Where x was equal to what?
7.5.
It's like
9.006468 3 blah blah blah, right? So for this assignment on page, what page is that?
745.
745, you're gonna do 1 through 23 odd and number 24. 1 through 23 odd and number 24.